think about it. How many were in here before they explode?
9.
How many are in here before they explode?
3.
Well, no, it's...
How many do you need to make them explode?
3.
You need 3.
You need 3 to make it. So if you have 3 in the 3 spot, how many is that?
That's 9.
You guys agree?
Yeah.
Because if you have 3 in there, and you have 3 threes, what does that make?
9.
Alright, so this one's 9.
The next one's 27.
So, would you guys agree?
Yes.
So it would be 27.
This is base 3, right? Oh, because base 2 you got multiplied. Oh, and the next one I think is multiplied by 81.
So this is the king out of all.
27 times.
Because this one overpowers this one, this one overpowers this one.
So let's leave that in there so we can see if our code works.
It does.
Does?
It does. Yeah, it's 81.
It's 81? So 81 would be this position.
It would.
27 times 3.
It would.
So let's backtrack and see if this,
0.
if we can transfer back to the other code.
The next one is 240.
So how would we figure it out how much was originally in here without counting it? Like we didn't have these to count back.
So I backtrack.
How can we backtrack?
They're all together. Well, I don't really get this.
Let's say we didn't even have marbles.
Oh.
Like we couldn't do anything. We couldn't backtrack and create those. Because this, how many does this represent?
9.
How many does this represent?
3.
How many total do we have then?
27.
Well, between this, how many? In this little pocket, how many?
6.
You guys agree? Why is it 6?
Because it's 2, 3.
Just 2, right? What about that? How many does that represent?
2.
How do we find the total amount there?
Okay, so you do 2, 6, and then is that
Together.
just 9? 2, 6, 9, so 15, 17. 17.
17?
Wrong.
Yes.
Oh, there's supposed to be another one in here, wasn't there?
Yeah, I messed up.
Okay.
Then that's 18.
Oh, this is supposed to be 1. Remember our code is 1, 2, 2.
So it's 2, 2, 1.
Okay, so
Okay.
it's still 17.
Where did we mess up?
Nowhere. We didn't mess up.
We have 17 or we have 21?
21.
You can try this one, Brody.
So 5 to 1.
So how many are we going to start with?
Oh, we're gonna start with 10. Because you
Only
said
10?
Well, you said 10 to 1.
We can convert anything to any
We're
code,
doing
right? Does it
fives.
matter on the number?
No.
Let's
Wait,
do
yes it
5
does,
to
because
1.
in all of that, you're gonna have to get back to the same number.
You do this.
Eventually, yeah. But does it matter how many we originally start with here?
Yes.
Does it? Can we convert any number to anything?
Oh,
Yeah.
yeah.
Okay. So how many are we going to start with?
We're gonna start with 22.
And we're going to do
We already had 25.
5 to 1?
We have 25.
25?
25.
We're going to find the code for 25.
I think I know it.
Do you know it off the top of your
Because
head?
if 21 is 1, 2, 2, it will have to be another one, and you have to add 3.
So what is it?
101.
So 1, 0, 1. So what's our code? Our decipher.
Okay, so it'd be 1, 5, 25,
So in this spot, what's that one represent?
1,
1? What about this one?
5.
5. Let's see if I can write upside down 5. Okay.
Oh, nice. 25.
And this is 25. Does it add up? Do you add what's in the beads or what?
Well, because
Dude.
last time we were
Really?
just
Whoa.
adding them all together, and we got the same exact number. Does it work with all of it?
Should it?
Well, it should, because we did it the last time the exact same way.
This is 1, 0, 25 equals 26.
Alright, so did we count correctly?
How
or did they get all
can
messed
1 be
up?
left over if we use 5
To 1.
to 1?
That means you put out 4 of them every for
25
every
goes equally into 20. Yeah.
So by nature it should be, right?
Yeah.
So what should have our code been?
1, 0, 0. No, it should have been
Well, depending on how you read
0,
it.
1.
0, 0, 1.
Why would it
Well, it's
I'll do 1 like that.
That's
So our code is
3. Can I help with this one?
3 to 1, 2, 2. And I'm going to say this is 4 to 1. You want to find what the original amount was in here.
But what are we going by? We can't do anymore.
You know, it was 4 to 1. We used 4 to 1 to get to that code. So how do we find out how many were in this bin originally? That's what you want to find out.
remainder 3, right?
No, because you have to add those together.
Do you guys agree with those?
Wait, did you get 128?
So explain what you did.
Okay. Well, if it's code 4, then it would be like, this is all 1 still.
Right.
Wait,
This
how
would
do
be
you
4.
Right.
This would be 16 because I did 4 times 4.
Right.
And then I did this times 4, which equals 64.
Right.
And
So all
then
powers of 4.
add them, I like multiplied these by each number that there was, and then I added them all together to get 520.
How'd you get
7, 32, and 128.
It would be 167, wouldn't it? Because you're doing 39 plus 128. You're not adding anything else because you did 7 plus 32, which added up those together. Then you just added 128, and it's 167.
Agree?
Yes, I agree to that.
You said it. Anyone else agree?
to it.
So what do you think it should be?
167.
You have 39 plus 128 is your last one.
167.
I put the 9 there.
Oh, let's see. Just have. So we would have had to have 167 Mancala pieces piled up. So you see
That'd be
how
awesome if
quickly.
you got that.
Can I set one up?
You want to set one up? Yeah. You got to set it up and you got to tell us what code it is.
1 to 1.
And it's got to be in its fully reduced form. So if you have code 5, what is the most you can have in one bin?
4.
Right. If you have code 7, what's the most you can have?
6.
10.
9.
9. Right. You're gonna make it real hard, aren't you?
Base 7.
Base 7. All right. So what is her code? What is your code?
First is
Sure.
3.
So 3, 3, 4,
4.
3, 3, 4, 3.
No, it's another 4. It's 3, 3, 4, 4, 1, 2, 3, 4, 5, 6.
6. And this is 7 to 1 code. All right. So you guys help Oleana. So what does she have to do to find the difference? What these are?
Draw the face. Roll them out.
How is she figuring this out?
She's doing 19 times 7.
It goes up by powers of what? You did give her a mean one.
Can I make one up next? Oh, please, just one more.
Want to make up one?
Yes.
Okay. I don't know how much time we have left.
We have, let me give me your iPad.
6 minutes.
Please.
So what do you think would happen if we used base 10 and we had a code?
Wouldn't it just, it'd be easy.
It would just be the same thing.
Why?
Well, because base 10 and everything to the base 10 is just its own self.
Why is that?
Well, because base 10 is like, you can't go, wait. I don't know. I've never asked Mr.
So while she works on that, if I gave you the code was 9372,
Really? 9372?
what is that going to be in base 10?
Oh, come
So
on.
this was using code.
9372.
Why is that?
Well, because everything to the 10th power.
Wait, what base are you
like
in?
this,
Base 10.
like this, like this. And then
What
every-
power is it 10? Is it each one going to be?
I don't know. Let's see. 9 times. No. Is it 3? 9 times.
I don't, isn't it 1 or 0? Isn't it 0?
I could have swore I did.
Do you raise the 9 to the power or do you raise the 10 to the power?
You raise the 10. No. Yeah, you raise the 10 to the power.
All right.
I
So
really-
what?
Well, wait, isn't it, if it's the 10th power, it would be up here. Instead of the 10th base, it would be, base is down here, 10 is up here.
Depends on how you write out the expanded form, I guess.
Oh, let's see.
So if you had
Hopefully I did this.
2 times, 'cause you know how we did like other ones, we had 2 times, to the...
Times 10 plus 2. That's expanded form.
So
And
if we were to add those up, what would we get? Should these powers of 10 always have all have the same power?
No. It'll be 1, 4, 3, right?
So what is 2 times 10? So does that represent the same thing there? Does that represent 20? What does it represent?
2.
Alright. So what power of that should that be?
0.
Alright, there you go.
Is this it,
7.
Mr. Chris? Yeah, I found it. It's right.
Alright, let's check it out, Brody.
Okay.
3, 3, 4. So what is 3 times 7 is 21.
321,
Good.
196, 172, and
Wow.
14,406.
So can you imagine trying to stack up 15,998 Mancala pieces? Or can you picture trying to do that using the box method?
I can picture.
So are there bases above 10 that we could do? Or is it just 10 is the last one?
K,
You
J.
can go to 11?
Wait, did you really just do that?
Yes.
Oh my goodness. I wouldn't have been able to do that.
Volunteer.